Hello everyone, welcome to SIT742 and this is the third video of this channel. So for this video, we're going to talk about some of the practice from the practice 1 and 2 in the past 2 weeks, and also we're going to talk a little bit more on the extension of the knowledge point on practice 1 and 2. So in practice 1 and 2, you're learning how to use the Python libraries such as pandas and numpy to processing the data. So at here, we're actually following that sort of the idea to actually make an example in this video. And hopefully by this video, you will have a really good understanding of how to use pandas and numpy to do the data slicing and indexing and processing. So at first, as normal, I'm trying to use Google Colab to actually make my work done here. And Google Colab, for many of you, if you know how to use Google Colab, and you should able to find out it's very convenient. And I didn't really change the title, so that's why when you actually open any sort of new Jupyter notebook, the title is always untitled. And for your own assignment or own tasks, you should actually change this title to your following understanding titles that you can remember. And also, I actually use code cells a lot in my script, but sometimes I will use text as well, and we shall see the examples later. So for the first code cell, and what I'm going to do is actually import several libraries here. And the first one is called numpy, and a very important one we're going to talk later. And the second one is the matplotlib, which is the visualization libraries, and the third one is pandas. And from pandas, I import some of the module called the data time, and also of course I import the math time and iter2s, and for the sklearn I import the pre-processing. And for the students who doesn't know sklearn, you should actually check it up in the Python, and because this is a very important libraries for future. And for the second code cell, I'm actually define two functions here. So the first one is called a sigmoid function, and the second one is called the reverse of sigmoid function. So if anyone who doesn't know sigmoid function, please check in the Wikipedia, and you can see this is the formula of the sigmoid function. It basically is 1 plus exponential with a negative x, and use 1 divided by those sort of results here. And by doing this, what they do is, if x, the range of x is from the negative infinity to the positive infinity, and by actually using sigmoid function, you can actually transform your x to a range of 0 to 1, and of course the middle point is 0.5. So this is a very important functions we're going to use a lot in the rest of the learnings for the modern data science. And so after I actually define two functions, and I actually use the pip install wget to actually import a wget library. So the reason of the use of wget library is I try to actually download a dataset by using wget. And now you can see I'm actually downloading a dataset from TutorLab SIT742, and this dataset should come from your practice 2. So you should be very familiar with this dataset. And after I downloading it, and I just run it, and you see the progress bar, and now it's finished. So now you can use this dataset for your future processing. So what I will do is I actually use the pandas library called the read-csv to actually read this dataset with certain conditions. The condition is for any sort of the byte lines. That means if during the processing the line cannot be processed, I'm actually just set a false on the arrow. So that means I'm going to skip that byte lines. And also I'm not going to introduce any headers for my CSV. And after that, I'm actually do sort of the slicing on my dataset, new data frame called dataset, and see that whether I can find out any sort of rows with a column from the fifth column to the rest. And if I run that, you can see 0 from the output of this syntax. That means perhaps this data frame doesn't have the fifth row. And now let's have a look of what's this data frame. So the data frame is called dataset, and I given this dataset to a variable called df, and I call it df and print out. You can see, so because I don't have any headers, so you can see this data frame have 6 rows with 4 columns and with a default header 0 to 3. And now actually I given a new header to this data frame and I name it the column with A, B, C, D. So, and then I try to print this data frame out. You can see that's a new data frame and with A, B, C, D 4 columns with all the rows, which is 6 rows. And what if I try to do a filtering on this data frame and with a condition called I'm trying to look that any rows who actually meet the condition on column A's value equals 1 and column C's value equals 5. And if you actually observe these 6 rows, you can see only the 6 rows meet this condition. So if I actually use this syntax to actually trigger the filtering, and just keep in mind there are several ways to do the filtering, but I'm just showing you one of the ways out. So it doesn't mean that you have to use this method for your filtering for your future always. So you can always actually use a different syntax. But here I just give you an example of how you actually filtering the data with multiple conditions. So if I run that, and you should only have one row, which is the 6th row, and you can see A equals 1, C equals 5. And what's more, remember what we learned in the practice 2, we actually try to use pandas to actually index and slicing the data. So one important function called illoc. So I try to actually use illoc to actually output all the rows, but only from the column of second to the rest. So I can use this syntax. And after that, what I'm trying to do is when actually slicing my data frames to a new data frame, and I'm trying to check that for the new data frame whether there's any of the non-values, and then we can use a function called replace with np nan to 0, and that means that if there is na or non-values in this new data frame called the data df final feature, and I'm going to replace this na or non-values to 0, and then I try to actually recheck that for when actually finishing this replacement, is there any of the NA values come out, and of course I'm going to call these new data frames out by actually using the slicing of the illoc. So let's run this. Now you can see that what I'm going to do is actually I select all the rows, but only select the columns from the second one to the rest. So you can see that's sort of the slicing syntax we use by using the illoc. Now you have a new data frame called the df final feature, and what I'm going to do is I'm going to transfer or transform these data frames to a numpy array. So what I'm going to do is I use syntax called np.array. np is a alias for the numpy library here. You define by yourself. So we define at first. So import numpy is np. So np is the alias. So after you actually use you defined a numpy to np, so you can use numpy to call the array function. And basically what they're saying of this syntax is actually transform this data frame to a new array called the data hyphen. So then I'm going to print out the shape of this new array and then print out the whole array. So as you can see, if you look at this array, this is a 2-dimensional array. So as I mentioned in my class, a 2-dimensional array, you need to find out how many rows, how many columns. So rows means they are horizontally aligned rows, and columns is how many columns. Pretty much easy to find out. It's actually 6 rows with 3 columns. The shape of them is 6 and 3. And after that, what I'm going to do is I know the shape of the array of data hyphen, but what I'm going to do is I'm going to create another array called y-1, and for this array, what I'm going to do is defaultly I'm setting all the values in the new array is zeros, so I use a function called the np.zeros, but I actually setting my new array with a certain dimension of the row dimension or the first dimension of the data